Boys and girls, today we are going to make a circuit, and we are going to control with the circuit the intensity of a light depending on how much is the light that we have in the ambient. So the higher the light in the outside, the lower the light we are going to use in our circuit, the lower the power. What makes a lot of sense. So if we have outside light, we don't need to create a light inside. The components that we are going to use is two resistors. One of them is 10K and the other one is 220 ohms. As the light source, we are going to use an LED. You know that an LED has two terminals, the cathode and the anode. The anode is the longest terminal and is going to be connected to one of the output pins of our Arduino board. Here we have the Arduino board that is connected to a computer, and the computer has one program, the program that we have created for powering up, for feeding this circuit. Other component is the light dependent resistance. This is the sensor of our circuit. This is the sensor. Okay, let's see now what is the diagram for our circuit. Starting from the left hand side, we have the two different resistors. This is the light dependent resistance. The higher the resistance, the lower the light, and the higher the resistance, the closer is the signal to 0 volts. Okay, so this is the 10K resistor, and this is the pin, the analog pin 0 from our Arduino board. This is the input for our microcontroller board, and the output is this pin 11, that is connected to our LED. So, and the LED for in one side is connected to the pin 11, and in the other side is connected to the series resistance of 220 ohms that is connected to ground. So this is the circuit that we are going to use. This is the program that we are going to run. Okay? Hello, boys and girls. Good evening. Today we are going to connect all the components that we need for our circuit. The circuit is going to control a light using an LDR. The source of light is going to be this LED. The higher the intensity of the light of the LED is going to be related with the amount of light that is in the ambient. So the lower the light in the ambient, the higher the light in our light source. Okay? So we are going to follow the connections that are shown here in our diagram. So the first component that we have to connect is the LED. The LED is going to be our source or of light, is going to be connected to the output of our Arduino board. The LED is connected in series with a resistance that is going to control the amount of power, amount of current that is going to flow through the LED. Using wires, we are going to define our power source, our 5 volts power source from our Arduino board. So this 5 volts is going to be connected to the red line of our board, and we are going to use this blue wire for the ground. So we take the ground connection from our Arduino board And that's it. We have defined the ground level and the 5 volts level. We have also connected the LED in series with the resistance, with a 220 ohms resistance that is connected to ground. In the other side of the LED, we have to connect the pin 11. So, using this wire, we connect pin 11 from our Arduino board, and we connected this output pin to the LED. As you can see, the LED is lighting just because we have already loaded the program into the Arduino board, into the Arduino card. Okay, so now we have to connect the components for the voltage divider. Here we have a voltage divider. We have two different resistances, two different resistors. This one is a fixed resistor. Is this 10 kilo ohms resistor, and this other resistor is going to be the LED. This LDR is going to be our detector. So we connect one terminal of the light dependent resistor to the 5 volts level. So this is our light dependent resistor. It has two terminals, so one of them connected to the 5 volts level. The other one is going to be connected to one specific place or location, and this is the common place. We have to connect this terminal with the analog pin 0 in our Arduino board. So we look for A0 and we connect this A0 with the terminal of the light dependent resistor. That's it. Okay. The other two connections. This is our LDR. Remember, the higher the light here in the LDR, the lower the light here in our light source. And we have to connect and make the connections for the resistance, for the other resistance in the voltage divider. So we connect one terminal to the resistor, and the other terminal of the resistor has to be connected to ground. So this is the ground level. That's it. So we have connected, we have made all the connections, and let's check if it works. So if we cover the LDR, the light is higher, and if we have light, if this detector detects the light in the environment, since we have light in the environment, we don't need so many lights, so that's why the LED is lighting less. Again, if we cover the detector, it detects that we have less light in the environment. That's why the LED is lighting a little bit more. I repeat it, we detect light. If our LDR, if our light dependent resistor is detecting light, that's why our light source is giving less light. If I cover, yes, as you can see, the light source has increased the intensity, what makes a lot of sense. The lower the light in the environment, the higher the intensity in our light source. And this is the end of our practice. Thank you very much for your attention.